Hey everyone, welcome back to the second session on merge sorting. And in this session, we are going to look at a more detailed example of how a merge sort works. If you haven't watched my previous session on merge sorting, I recommend you do that so that you have a basic idea of how merge sort works and so that you are able to follow this example more clearly. So as we discussed in our previous session, there are three steps: divide, which is dividing the sequence by 2 every time, then sort, and then merge. Okay, so if we divide this array in two halves, we get this, right? So if here the problem size was 8, here the problem size is 4. Two, 7, 5, 4, 1, 3, 2, 6. Okay. Now again, we are going to divide the problem size by 2, and we are going to get a few problems whose sizes are 2. Right? Now, if we divide again, this time we get problems whose size is 1. So okay, right. Now this finishes our first step. Finishes divide step. Now we are going to sort. So we sort these two, and then as we start sorting and combining, our problem size will start to grow again. So now we get 2 and 7. We sort these two and we get 4 and 5. We sort these two, we get 1 and 3. We sort these two and we get 2 and 6. Fine. I hope it's not too tough to follow. Okay. Now when we combine again, our problem size will be 4. Now see, every subsequence is already sorted. This means we are trying to sort two subsequences which are already sorted into another sorted sequence. Okay. Which means how we are going to do that? If we think about code, how the code is going to look like, although we are not doing a coding session here, but we are preparing a bit for the coding session which is going to come in our next session. So we have two indexes. We compare the indexes, the value at the indexes. So let's say this is I and this is j. Whatever is smaller is going to come here, and because I was value at index I was smaller, it came here, and I is going to increment to here, right? Now we are going to again compare values at index I and j, and this time we see that the value at j is smaller, so we get 4 here, and j is incremented to 1 from 0, right? Then we again compare and we see the value at j index is smaller, so it comes here. After that, we are left with one value which comes here. Same for the other subsequence. I is equal to 0, j is equal to 0, 1 is smaller, it comes here, I is incremented to 1, then 3 and 2 are compared, 2 is smaller, 2 comes here, I is incremented, right? I'm sorry, j is incremented, then 3 and 6 are compared, 3 is smaller, 3 comes here, and after that 6 comes here. So we get two subsequences which are already sorted, and this is going to be our final step, where the problem size is going to be our original problem size. Okay, let's see again. I is equal to 0, j is equal to 0. We are going to compare values at I and j. Value at j is smaller, 1 comes here, j goes here, j is 1, 2 is smaller, so 2 comes here, j goes here, j becomes 2, then 3 and 2 is compared, and this time we say 2 is smaller and we pick I value. So when we saw values which are equal, we can pick any of the values. So in that case, we picked the value at the jth index and j was incremented. Okay, and now we compared value 3 and 2, and because 2 is smaller, 2 came here and I is incremented to 1. Then 3 and 4 are compared, 3 is smaller, 3 came here, j got incremented. Then 6 and 4 are compared, 4 is smaller, 4 came here, I is incremented to 2. 5 and 6 are compared, 5 is smaller, 5 came here, I is equal to 3. Then 6 and 7 are compared, and because 6 is smaller, j is, which goes out of the array, and then we have 7. So this is a very high level of how the algorithm works. There are more details which we can look in this same session, and then maybe we can look at the code in our next session. So let's do this example again and do it in a way which explains how our code is going to look like. So I'm going to discuss one important detail about merge sort in this discussion. Okay. Now let's number them from 0, 1, 2, 3, 4, 5, 6, and 7, right? So if we take out mid of the array, which will be, so the L, we have L is at this time, L is equal to 0, R is equal to 7. So then mid is going to be L plus R upon 2, which will be 3. So mid is equal to 3. 0, 1, 2, 3. So we are dividing this array at the midpoint. So we are going to get two arrays, 0 to mid, which is 3, and mid plus 1, which is 4, to right, which is 7. Okay. So we get try to follow this discussion, because this will make the base for the merge sort code. 2, 7, 5, 4, 1, 3, 2, 6. Okay. So then this is 0, 2, 3. This is 4, 2, 7, which means L is 4, R is 7, and mid is mid 1, mid 2 is 7 plus 4 upon 2, which is 5. So we are going to divide at the boundary of 5, and mid 1 is going to be 0 plus 3 upon 2, which is 1. So this is 0, 1, 2, and we are going to divide at the boundary of 1. Okay. So then here L is equal to 0, R is equal to 3, and mid is equal to 1. Here mid is equal to 5. So we get okay, 2, 7, 5, 4, 1, 3, 2, and 6. Now next iteration, L is equal to 0, R is equal to 1. Here L is equal to 2, R is equal to 3, L is equal to 4, R is equal to 5, L is equal to 6, R is equal to 7, right? Great. So mid 1, mid 2, mid 3, mid 4. Mid 1 is 0, mid 2 is 2, so this is 0 and 1, 2 and 3, 4 and 5, 6 and 7. Mid 3 is 5 plus 4, 9 upon 2, which is 4, and this is 6 plus 7 upon 2 is equal to 6, and this was 2 plus 3 upon 2 is equal to 2, right? And this was 0 plus 1 upon 2 is equal to 0. So we are dividing these arrays at the midpoint. Mid 1 is 0, mid 2 is 2, mid 3 is 4, and mid 4 is 6. 2, 7, 5, 4, 1, 3, 2, and 6. After that, when we try to divide them again, we have L equal to 0, R is equal to 0. When we have L greater than equal to R, we stop dividing. Or we want L should be less than R. This cannot happen. This is fine. So in this case, L is 0, R is 0. We stop dividing. Okay. So then our first step is finished here, and we start to sort. So here L is equal to R is equal to 1. This is 2, this is 3, this is 4, 5, 6, and 7. Right? Okay. Now our merge function is going to be we will have L, M, middle, and R. Okay. And how this is going to work? We go from left to right until any one of the array is done. So then what we need is size of the first array, which is 1, size of the second array, which is 1. If we go past any of these arrays, we are going to stop. Okay, this is one thing. Second thing is, which is important, merge sort is not a in place algorithm, which means when it merges, it creates new arrays where it places the values. So in our sort and merge step 1, it is going to create two arrays. So let's start from here. 2, 7, 5, 4, 1, 3, 2, and 6. Size of this is 1. Size of this is 1. We are going to create two arrays, transfer the values here. After that, combine these indexes, which are now empty. Compare these two values 2 is smaller, so we are going to do the same. I is equal to 0, j is equal to 0, to size 2 and to size 1. So we see 2 comes here and then 7 comes here. Okay. After that, so now these two are combined. Now we are going to take these two and we do the same logic. We create two arrays of sizes 1, transfer the values 5 and 4, and these indexes we consider to be empty. Compare the values. 4 is smaller, same like I is equal to the indexes were 2 and 3. So this is, but because so we have empty indexes 2 and empty indexes 3, and these indexes are going from 0 to size 1, and this is j is 0 to size 2. So 4 will come here and 5 will come here. So if you see, we have 3 indexes in play, one for this, and one for this, right? Okay. Now let's say we did the same thing and this is sorted. We did the same thing and this is sorted. Okay. Now in our next step, step 2, where the problem size is R2, we are going to create arrays of size. So S1 is equal to 2, S2 is equal to 2. We are going to create two arrays which are going from 0 to 1, 0 to 1, I, j, and we are going to transfer the values here and we combine these and keep them here. So I, j and k. K is going from k is going from 0 to 3. So we compare 2 and 4. 2 is smaller and I is incremented to here. Then 4 and 7. 4 is smaller. 4 comes here. J is incremented here. Then 7 and 5. 5 comes here. And as soon as we reach one of the arrays and end of the arrays, what we are going to do is we are going to transfer all the values here, because we know that both the arrays are sorted. Whatever values are left here are actually going to be sorted. So 7 will come here and we do nothing. Similarly, we do the logic here and we will get 1, 2, 3 and 6. Now for our final iteration, we are going to create an array of size 8. Oh, I am sorry. We are going to create two arrays. S1 is equal to 4. S2 is equal to 4. We will transfer the values 2, 4, 5, 7, 1, 2, 3, 6, and then we are going to merge all these indexes and consider them empty. And then we will have I is equal to 0 to 3, j is equal to 0 to 3, k is equal to 0 to 7, right? Okay. So we compare 2 and 1. 1 is smaller. 1 will come here. J is going to increment. Then we compare this 2 and this 2. Let's say we pick this 2. So 2 comes here and j is incremented. Then we compare 3 and 2. 2 is smaller. I is incremented. We compare 3 and 4. 3 is smaller. J is incremented. We compare 4 and 6. 4 is smaller. I is incremented. We compare 5 and 6. 5 is smaller. 5 comes here and I is incremented. We compare 6 and 7. 6 is smaller. We go past one of the arrays. We don't do any of the iterations. We just pick the other array, which is where we did not go past the array, and copy all the values which are left. And that's how it finishes the merge sort algorithm. So this was a very basic and high level session where I gave the example on the basis of how you are going to code the merge sort. This was not the actual code, but probably this give you a heads up on what is going to come and how you can code a merge sort. I'm going to end the session here, and we'll see you in our next session where we will see how the merge sort code look like, and we'll do the analysis of merge sort. Thanks for watching, and bye for now.